Alrighty, welcome back everybody. Today we are doing the last area of network fundamentals, which is extending your network. So we're going to be learning about some of the technologies used to extend networks out onto the internet and the motivations behind this. So starting off, we're going right into port forwarding. So port forwarding is an essential component in connecting application services to the internet. Without port forwarding, applications and services such as web servers are only available two devices within the same network. So over in this diagram, here we have what appears to be a like web server. It's running on port 80, so that HTTP port that we went over. And we have other endpoints on this network that can see it at its 192.168.1.10 address, but it is a web server, so it probably wants to try to serve requests as it's hosting a website, something like that. So if an admin wants to do that, they need to implement port forwarding. So in this diagram, we still have the same network that we just went over, this little internal network. And over here, it's in the blue is a second network. So this guy's IP is his public IP is 172.68.43.21. So that's over here. He's going to use routers to connect over their net to port 80 of 82.62.51.70, which is the public IP address for this network space. So this web server has its internal, like its private IP of being this on this network. So the private network IP is at its public IP address is over here for the network, and they're just forwarding it over. All right. So we're not going very deep into this, but that's what port forwarding essentially is. It's allowing internal assets to also communicate to other what entities, whatever we really want to call it. So this up here was a much cleaner definition. So just go with that. And most of this is done on routers up at that layer. So what is the name of the device that's used to configure port forwarding? It's a router. Next, we're going into firewalls, which I feel a little bit more comfortable talking about, honestly. So, a firewall is a device within a network responsible for determining what traffic is allowed to enter and exit. Think of a firewall as a border security for a network. So, an admin can configure a firewall to permit or deny traffic from entering and exiting network based on numerous factors. We'll go over those, but there's going to be a whole bunch of rules that you assign to a firewall, and they're either denying traffic or they're permitting traffic, okay? And you do want to think about things like where's the actual traffic coming from? Are there certain countries that you don't want traffic coming in and out of? Where is the traffic going to? What port is it going for? So if you're hosting a web page on a web server, port 80, that's at HTTP, port 443, HTTPS, you probably don't want to be allowing, some traffic maybe on port 22, that SSH one, because externally, you probably don't want someone who you don't know to be able to be doing SSH traffic over to your web server that you don't know about. Um, what protocol is it using? So you can identify for UDP protocol, TCP, or both of them. And firewalls do this. Um, in order to answer these, they perform packet inspections. So there's a whole bunch of different types of firewalls, software defined, hardware ones, standalone devices. Some are bundled into other things. But we're going to go over two kind of main categories here, which is stateful and stateless. So you can go ahead and read the descriptions, but stateful is when is using the entire information from the connection rather than inspecting individual packets. So it's based on the entire connection, and in doing so, it eats up a lot of resources. In order to do that, um, that's just a way to stateful. It just requires a lot of resources to be doing that because there's so much traffic that's going on. Now, stateless, uh, you use stack set rules to define whether or not individual packets are accepted, and then If the packets are determined to be bad, the device itself does the device itself is not immediately blocked unless if it's oddly configured like that. But in stateful stuff, it will block the entire device. Stateless, it's looking at the packet, so it might just be blocking the packets. All right. It says that stateless, uh, they're much dumber, which I think is funny. But yeah, it is as good as you are going to be defining it. So there's a good amount of upkeep necessary. But hey, when it works, and they are much cheaper to run than stateful, and a little benefit. So it says that these firewalls are great when receiving large amounts of traffic from a set of hosts, such as from a DDoS attack. So let's go ahead and answer these questions. What layers of the OSI model do firewalls operate at? That's going to be at our 3 and 4. So layer 3, layer 4. Boom, we're talking about routers or anything like that. So what categories of firewalls inspects the entire connection? So between stateful and stateless, stateful ones inspect the entire connection, while stateless firewalls inspect individual packets. All right. So we're going to go onto a practical really quick. So it says deploy the stack site attached to this task, which we did. Malicious traffic are marked as the packets in red. The legitimate traffic are packets marked in green. The protocol you need to block is port 80. Configure the firewall to prevent the malicious packet from reaching the web server at 203.0. Okay, so we're gonna have two endpoints. They're gonna be sending traffic. One's gonna be green. One's gonna be red. They're gonna be sending the traffic through the router and hitting our web server right here. We need to put in a firewall rule blocking one of them over here. So let's go ahead and start the simulation. And if we look, okay, we have red packets coming from this guy, green from this guy. So this top one's bad, and that's at 198.51.100.34. Destination IP is going to be our web server, and that is 203.0.110.1 on port 80, and we want to drop. So if we go ahead and add in that rule, alrighty, hey, there we go. We save the server. That was a little bit fast, honestly, so we can go ahead and oh, there we go. I kind of want to launch it and take a little bit more time. Let's look at this. So we know bad packets are coming from here, so that's going to be your source IP. Your destination IP needs to be your web server, all right, because the packets are coming from here to here. Out of all of our different ports, it does give us in the instructions to block port 80. When we are thinking of web servers, well, HTTP, things like that, it would be port 80. And the available actions are either going to be drop or to pass. So this is your, deny and allow essentially. So we definitely don't want to allow it. So dropping it is a proper thing there. So we didn't have a lot of time to do that, but it is a very good little visualization of what's going on here. So let's go ahead and close out of that, and we'll move on to VPN basics. I'm sure everyone has heard of what a VPN is, whether it's on a advertisement or not. But a VPN is a virtual private network, and it's a technology that allows devices on separate network to communicate securely by creating a dedicated path between each other over the internet, known as a tunnel. Devices connected within this tunnel form their own private networks. So, for example, only devices within the same network, such as within a business, can directly communicate. However, a VPN allows two offices to be connected. So let's look at this diagram where there's three networks. So we have gray being network 1, purple being network 2, and network 3 are these blue guys over here, which is the VPN. So we have two different office spaces, and then kind of their own in the office space, are there's a VPN established between these two devices. All right. So even though physically they're at separate locations, so they could be different offices, it could be different floors, it could be different countries, different states, whatever. If they are on the same VPN, it is going to act as such. They are on their own private network. All right. So this guy might not, like one of these computers over here in the gray, it might have certain rules configurations not allowing it to communicate properly to the purple network or vice versa. Like maybe only the assets on the gray network can see each other, only on the purple, and the blue one's the same, which you just have to remove the physical element of it. It is a virtual private network, alrighty? Virtual private network. So it says these devices on network 3 are still part of network 1 and 2, but they also have their own of private network amongst blue. So cool. Let's cover some of the other benefits. It allows networks in different geographical locations to be connected. Yep, so we kind of hit on that. Offers privacy. So VPN technology uses encryption to protect data. This means that it can only be understood between the devices it was being sent from and destined for, meaning the data isn't vulnerable to sniffing. It can offer anonymity. So journalists and activists depend on VPNs to safely report on global issues in countries where freedom of speech is controlled. And then it goes into usually your traffic can be viewed by your ISP and other intermediaries and therefore tracked. The level of anonymity, that's a fun word. A VPN provides is only as much as how other devices on the network respect privacy. For example, a VPN that logs all of your data history is essentially the same as not using a VPN in this regard. On the consumer level of things, when you have all these VPN services, look at the terms and conditions to see what they're actually doing, look up reviews of them, because I've definitely been in conversations where people essentially think that they're untraceable to do whatever on the internet because they use this VPN, and the VPN service it logs everything in the history. So it's nice to be able to say you're in another country, maybe to stream something, but it just depends on the actual product being offered. Many organizations use VPNs. Um, I mean, we're in a world where so many people either work from home or work remotely and such, and VPNs allow like their laptop, let's say in Bali, to connect to their local internet that's hosted, let's say in Colorado or something like that. So that's pretty cool. Then it says TryHackMe uses VPN to connect you to vulnerable machines without making them directly accessible to the internet. So that's pretty cool. Later in exercises, we're definitely going to be doing that. We're going to be starting up their little attack boxes and the hosts that they have, and you'll see that there. Alrighty. So VPN technology has improved over the years. Let's explore some existing VPN technologies below. So the first one is PPP. So this technology is used by PPTP to allow authentication and provide encryption of data. VPNs work by using a private key and public key certificate, similar to SSH. A private key and certificate must match for you to be able to connect. This technology is not capable of leaving a network by itself, so it's non-routable. All right. Next is PPTP, which is point-to-point tunneling protocol, and it's a technology that allows data from PPP to travel and leave a network. So point-to-point tunneling protocol is very easy to set up and supported by most devices. However, it is weakly encrypted in comparison to its alternatives. One of the alternatives being IPsec or Internet Protocol Security, and this encrypts data using the existing Internet Protocol framework. So IPsec is difficult to set up in comparison to alternatives. However, it's successful with both strong encryption and support on many devices. So you'll see that with a lot of things. There's a give and take. So easy to implement, might not be the strongest, while more secure does require more resources. I mean, earlier when we were talking about the firewalls with the stateless versus stateful, we were thinking, well, why would you not want the one that's, you know, not not dumb? Why wouldn't you want the smart one? Because of resources, time, and money. All right. Um, see, so let's go to the questions. What VPN technology only encrypts and provides authentication of data? That's going to be that PPP. What VPN technology uses the IP framework? So if we're looking at either PPP, PPTP, or IPsec, it's going to be IPsec. Alrighty, cool. Moving on to LAN networking devices. It's going over what is a router. We've kind of already covered that, so I'm not even going to be reading this. What is a switch? We've also covered that. If anything, just remember routers are layer 3. l- Switches primarily are layer 2. All right. Boom. Du- 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 du. Okay, here we go. And there are layer 3 switches. I was wondering if they were going to hit on that. So these switches are more sophisticated than layer 2 as they can perform some of the responsibilities of a router. Namely, these switches will send frames to devices as layer 2 does and route packets to other devices using the IP protocol. So this is showing a diagram with a VLAN. So that's a virtual local area network, and it allows specific devices within a network to be virtually split up. So this means that they can all benefit from things such as internet connection but are treated separately. This network separation provides security because it means that the rules in place determine how many specific devices communicate with each other. The segregation is in this diagram below. So in this diagram, we have the router, we have this switch right here, which is hosting two different IP addresses. We got this 192.168.1.1 and 192.168.2.1. Okay, so it's not in that the fourth octet, it's in the third one now. Okay, and how they separated this is probably in the same office building. It's the same networking closet because it's the same switch. You have the sales department, which is going to be on VLAN 1, which is designated by the 1 in the octet, and the accounting department, which is VLAN 2, which has the 2. They could be on the same floor, they could be right next to each other, adjacent cubicles, but how this is being segregated separated, not segregated, um, is no, it is segregated. There we go. The segregation. Wait, okay. It's just how the administrator wants to administer their network. So you might have different rules that are being applied to the one VLAN 1 versus VLAN 2, or you just might want that line to prevent whatever policies or rule sets, whatever it may be. But you're going to see a lot of VLANs. You're going to run into a lot of VLANs. There's going to be a lot of VPNs. Like everything in this, it's very just high level. We're not going very deep into it. It's just to let you know about it. Remember, this is fundamentals. So as long as you generally can understand already, a VLAN is not the same as a VPN. All right. They're not, even though diagrams might end up looking kind of similar with, hey, this guy's connect over here, this one's connect over here. Now they can use each other's technologies as well. It just depends on how everything's set up. All right. So what is the verb for the action that a router does? So routers do routing. All right. They don't do switching, they do routing. And what are the two different layers of switches? So switches operate at layer 2 and layer 3. Next, we're going to go into this network simulator real quick. So it says deploy the stack site attached to this task. Alrighty. And experiment with the network simulator. The simulator will break down every step a packet needs to take to get from point A to point B. So try sending a TCP packet from computer 1 to computer 3 to reveal a flag. Alrighty. And then it says, please use Chrome or Firefox browser to complete this practical exercise. I'm using Edge, so hopefully it'll be fine. Alrighty. So it says from computer 1 to computer 3, a TCP packet. Let's go ahead and send this packet. And if we look, it's going. That was probably that was blue, so that was the ARP request. Next is the TCP handshake packet. ARP packets over here to identify it properly. Then it's sending its TCP handshake packet back, and now it's sending another TCP handshake. Now the data actually gets to go. So the TCP packet of whatever it was actually sending, this looks to be the acknowledgement, bam, and what do you know? We have a flag right there. Alrighty. So that was cool. But this exercise right here, let's answer this question before we move on to. So, how many handshakes entries are there in the networking log? So we got one, two, three, four, five. Alrighty, five. All right. We're going to go back into that exercise because was not done with that. But we got badge. We got all this stuff right here. Close. All right. We're going back into this because this is fairly useful. Um, so that was a TCP packet. And if we look at the networking log, we're starting the handshake. We're sending a packet, routing, where it's saying, hey, computer one says to computer three, it's not on my local network, saying it to the gateway, which is the router. And then it's an ARP request, who the router says, who's computer one? The ARP response, hey, computer one, I'm a router. Then the request, who who is computer three? And the ARP request, then from the router, if you remember, it was over here. So it went like bam, the blue packet went over, and then this guy's gonna say, I'm computer three. So now ARP wise, remember, the ARP table is where we're taking the MAC address and IP address to properly identify devices on the network, right? So now that at the routing level, we know where stuff's supposed to go. Now the handshake can actually start. Okay. So we have the handshake. Computer three receive that send packet, and then it sends its own SYNAC packet back to computer one. All right, computer one receives it. It sends the acknowledgement packet over to computer three, and then computer three says, "Okay, I got your ACK packet packet," and it sends it back to computer one. Then the handshake is good to go. They're happy. Alrighty. Now the that actual data transmission gets to start where TCP, same TCP packet from computer one to computer three. Cool. And then computer three gets it and then sends the acknowledgement packet to computer one saying, hey, I got this data. I'm happy now. So all of that was done right here. Oh, and if we look, now there's not ARP packets because it's already been defined. All right, so they're doing their handshake. He's going to go. Once that goes, then the actual data, and then computer three is going to send the acknowledgement packet back. Alrighty. So they're not going to do the ARP request every single time once they know about it. I do want to show what now UDP looks like. So if we remember going through the whole three-way handshake, everything, that's for TCP IP. For UDP, much more simple. Remember, this is more like streaming video and stuff. So the UDP packet goes, and that's it. All right. Literally, we're saying, hey, from computer one to computer three, send a UDP packet. UDP3, computer three received it, and uh, computer three went and got it. So we are going to close this and launch it again to show what it looks like when it doesn't have um, the knowledge of where it's going. So it has to start again with that ARP packet, okay? But it didn't go everywhere. All right. It didn't do the same ARP process as TCP/IP. If you notice, last time it went all the way through. This one, it stops over here. So the ARP request, who's computer one? Tell computer one. Hey, computer one. Oh no, I messed that up. My bad. There we go. So computer one is trying to find computer three. There we go. Alrighty. So if we looked at that, ARP packet goes, stays at the router. The UDP packet goes, stays at the router. Then it's going to identify over here once the ARP packet has gone and the response comes, then the UDP packet just gets sent over. It's not a full back and forth what's going on. It's a one-way flow. All right. So that was pretty cool to see. I wish there was a reset button on this. Let's do that. And let's do a ping request. ARP goes out, boom, ping, ARP, response, ping, okay. And then we would do from 3 to 1 with a ping response being sent back. And he just sends that packet right on back. And that's going to look different from like computer 1 to computer 2, like if we're doing TCP. Our packet goes, he says, hey, that's me with a response. All right, let's start doing the handshake. Send, send act, boom, data, act to end it. So on the same network over here, so they're both connected to switch 1. That doesn't require as many steps. Well, it's still going through the same steps, but it doesn't have to traverse over the router. So that is a very useful tool to visualize how these handshakes are occurring, how the packets actually flow. I would recommend like this network simulator, this practical is worth much more than all these other tasks. All right. Go in here, start spamming stuff, just see how it goes. All right. Like see what's actually going on here. Like start clicking and be like, okay, well, what does this look like with so many, you know, we're doing our requests. There's a couple different things that you can go through for packet types. So TCP, UDP, ARP request and response, and ping request response. Go through, see how it goes so that you get an understanding of this flow using the different protocols. All right. With that, I'm going to go ahead and end this video. Oh no, this is probably why I didn't want me to use Edge, but I'm gonna go ahead and end it. Congratulations if you have been following along, because now you are complete with the network fundamentals module. So good job, everybody. Next up, we'll be going over Linux fundamentals. So, or I'm assuming that's what's next in this learning path. That's a fun section. Thank you all for watching. Take it easy.